Hello everyone, and welcome to today's webinar, Improve Product Design with AI-Driven Parts Standardization. My name is Maria Ma, the Marketing Campaign Coordinator for Engineering.com, and I'm happy to welcome our speakers for today. We have Ken Barrett, NETVIBEs Senior Sales Expert for Dassault Systèmes. With over 25 years of complex solution and value-based selling experience, Ken's specialty is uncovering customers' specific business needs, objectives, challenges, and requirements, and mapping them to solution benefits to exceed expectations. Also with us is Rob Doneth, NETVIBEs Senior Industry Process Consultant for Dassault Systèmes. Rob is an acknowledged technical, sales, and marketing professional with 30+ years of involvement in software, manufacturing, and consulting. Now, before we get started, we'll first cover a few housekeeping items. Today's webinar will be recorded, then available for on-demand replay on engineering.com. For attending this full live session, you'll receive your PDH certificate within 48 hours. And if you have any questions, please submit directly in your webinar interface, and we'll try to address all questions during Q&A. Now, without further ado, I'll pass it over to our first presenter. Ken, over to you.
Thanks, Maria. I wanted to start out with just a quick introduction to Dassault Systèmes. Not sure everybody on the webinar here today who might know who we are, but just to share with you our proven transformation, leadership as a company over the last 40 years, from way back when folks were developing and designing on drafting boards to moving into 3D design with our introduction of our CATIA product, to years later introducing digital mock-up, 3D digital mock-up, to one of the innovators of the first PLM, product lifecycle management solution, to one of our more recent areas of a 3D experience platform. And think of the platform as an all-encompassing platform for end-to-end design, from integrating manufacturing, simulation, really anything else within the product development process. And then to our newest endeavor with the creation of the virtual twin, where it's the development of a virtual reality, using virtual reality to create something before it's produced, to be able to really understand the impact of a product prior to moving into any kind of production environment. And as you can see over the years, we're not a company that thinks we're the best at everything, but what we do is look for companies that are the best in everything, and then we look to acquire them and then integrate them into the Dassault ecology and into the platform. And one of those products that was acquired over the years was our sourcing and standardization solution. So NPI for us is new part introduction powered by AI. So these are just some of the typical challenges that we've seen with customers over the years, and the number one is the disconnected multi-CAD environment. So we look at customers who might have grown like we have through acquisitions, or are supporting multiple OEMs or tier ones, where there's a requirement to have different CAD technology. So using a core CAD to develop for a particular customer is often the case. And unfortunately, that information is typically kind of kept within that CAD environment. So not having that ability to connect different tech or parts or technology that's been created because of the CAD it was created in. Experiencing a very lengthy reuse, buy, or make decision process. And this is one of the number one problems. Is a lot of times we have customers telling us that engineering design say it's faster for me to build something or design something because I can't find it. It's difficult to use. Can't find the information that I need, so I can't make that decision. So I'm just going to build it again or create it again. No cross program or part classification standardization. So customers of ours like Eaton and Parker might have 30 different divisions, and all of those different divisions are running semi-independently, and those different programs that are being developed within a company, there's not a way to connect those different companies and information to leverage any kind of efficiencies they may have learned in their development or design process. And then missing part attribute information for decision making. This is a common thing because, again, data kind of sits in different places. So sometimes the CAD information is not enough, or different requirements around keeping attribute information around material compliance or ITAR or export control, all of that information, being able to associate that back with a part. So when somebody's making a decision, they have all the information they need. Does that bolt have the right coating, or is it heat treated? So can I reuse it is very difficult when you don't have all the information that's needed. So we validated this with just some industry analysis that we trust and work with. Aberdeen Group has shared with us that 45% of an engineer's time is spent searching or recreating parts. And again, that we've had engineers tell us, hey, you know what? I can build it faster than I can find it, so I've saved the company money. And what they don't understand is that each of those parts typically has a carrying cost of around $4,500 to $23,000, and we're told in some of our more complex parts even more than $23,000. So that, not to mention all of the risk that they're introducing to that design, but that downstream effect cost is really not typically understood at an engineering design level all the time. And then about 80% of the work that's done in an engineering department is identical or very similar to work that's been done previously. And we'll share with an example at Parker here at the end of the presentation, but this is common where that information is available or been reused, but it hasn't been able to be leveraged based upon their ability to access it. So with that, I'm going to turn it over to Maria real quickly for a poll question for everybody here.
Awesome. Thank you, Ken. Attendees, please let us know. Do you think these industry numbers align with what you see at your company? Yes or no? We'll give you a moment to respond. And here are the results. 70% selected yes, with 30% selecting no. Thanks so much for participating. Ken, back to you.
Thank you. Yeah, the 30% doesn't necessarily surprise me. A lot of the time we find that engineering design feel they're building a part for a particular reason, right? And it's usually they don't really understand that there's that many parts within their system. We have an OEM we were working with that assured us that they had a very rock solid new part introduction problem or a process that was handled. And when we showed them the results that they had, we'd found parts that were similar to the tune of about 100 of the exact same part. They then said, well, yeah, we definitely have a problem. So we'd definitely be interested in talking to those 30% and see if we could talk to you a little bit about that number. But our goals for today are to identify parts for reuse and making it faster than creating a new one. So we need to make it more efficient for a designer to find a part than it is for them to create it. And that's the number one goal there. To get a comprehensive view of all the parts created, regardless of the core CAD. So looking at the parts, we build a 3D similarity score of a part, and then we automatically compare the parts based on the geometrical shape of that part. And then what we allow you to do is we automatically highlight the differences of those parts based upon the similarity. And Rob's going to go into that in detail with the demo, but making it very easy for you to look at the parts that are similar. And you can set the similarity to 100% or 50%, but we're going to show you what's different because it might just be location, it might be something to related to cost or inventory, so not really the integrity of the design. But we're going to show you how we can do that today. And then access the specific engineering related critical information to be selected. So sometimes finding the part is just not enough, right? You need to find FEA studies, you need to find material compliance, other associated documentation that is parent-child information that's required to pick a part, and sometimes seeing different data sources. So we'll show you a little bit today on how we can do that as well. So we'd like to say we are data location, data format, data CAD agnostic. So when we find out some of the issues for people looking for parts, it's based upon, well, we couldn't find a part because it was named different or it's a different core, different CAD. again, our search is done on the geometrical shape of a part. So we don't look at, and that's where our AI and machine learning come in, right? We look at geometrically how that part is set up and how it looks, and we can, go into more detail later on how that actually comparison is done. But once we do that geometrical shape of the part, the other information, the CAD, the location, all that just becomes a search function within the technology. So if we've identified parts that are similar and you wanted to pick one because it's in a core CAD, then you could do that. But we don't care about the data format, the location. We just look at the data or the geometric shape of that part. And an important part to this too is we're not converting data, we're not translating data, we're not creating a new system of record. We work on the index similar to the internet, where we're looking at just some key identifiers of that data, and then we go and pull it and then run our comparison. So it's really important to note there is no data conversion. And the other thing that allows us to do is we can then bring in other sources of data that we could associate then with that part number. So bringing the kind of the CAD and the ERP worlds together for supplier information. So if you're looking at two parts, they're identical, one's cheaper or one that you have existing inventory, it allows you to bring that ERP data and the supplier data, or really any kind of attribute data that might be sitting in a different data source, and bring it and then allow it to be associated with that part, and build it actually into the similarity score that we would set up, or an attribute that you might want to be assigned to that part, and then giving you that what we call the full 360-degree view of a part. We talked a little bit earlier about the some of the engineering design having a belief that I can design it faster than I can find it, so I've saved the company money. And we talked about the carrying costs, and we look at the downstream effects. When you think of a new part and looking at CAD design, validation, all the approvals, testing, prototype, again, the introduction to risk, tooling changes, procurement, sourcing, supply chain, all those elements obviously take a lot of time. So when you think of an efficient reuse policy, if you find a part and you can eliminate that design, approvals, testing, prototypes, introduction of the risk, the tooling changes, procurement, sourcing, your time to market is actually faster if you have an efficient process for finding a part. So this is part of the process we're talking about later as well. The importance of a new part introduction process is to really buy in and understand the downstream effects of cost for introducing that new part. So with that, I'm going to turn it over to Rob. We definitely want to get you into the product, and then we'll finish up with some slides with me at the end. So Rob, I'll turn it over to you.
Thank you, Ken. So as Ken mentioned, there are sort of four key areas that the solution set is really defined to help with, and that's around operational efficiency and reuse and redesign, cross-program reuse, and supplier variability. And as part of that solution set, we have several application pieces that overlap to some extent because they take place and handle different portions of those challenges. The first one here is one part reduce, where we're using this to do standardization, classification, and help to publish this sort of enterprise parts policies back in through engineering and through procurement, et cetera. One part reuse, which is really more at the design aspect or design phase, where I'm in a design, I'm looking to find a part that may suit the need that I have. We'll look to see if we have something already. It helps you reuse standards in real time through your design process, and I'm going to go through some demonstrations of this. If I don't have a design or a part that I can reuse, maybe there's something out in the enterprise, someplace out in the cloud. Organizations use external part catalog systems to look for it. We have a solution called Part Supply with a community of parts. I'll demonstrate how this kind of works together, but this also can provide a cloud-based sort of sourcing strategy to unify both procurement and engineering, and potentially also make that available for suppliers to put their content up so that you can get that content as part of the engineering and design phase. And the last one is that we have all this parts related information. We have information about supplier relationships, supplier information, and this procurement intelligence application allows me to go into overlay, parts data along with usage data, along with all of the purchase ordering information, and so I can do analytics, understanding supplier variances, which suppliers are continuously more expensive, or if I need to find an alternate supplier, is there a supplier who we already have who manufactures something that's close to something that we need to replace or resource, and could potentially become a supplier for that product. I'm not going to go too much into the procurement intelligence application at this time, but I wanted you to be aware it's part of the overall solution set. So I'd like to jump right into the demonstration if I can. So as you can see here, I'm logged into a system through the 3D Experience platform in this case. As a parts manager, I have access to the one part reuse application where I can look at standardization activities. We have the ability to sort of cluster data. So we're going to use AI related activities. I'm going to create a universe of parts, and in this case, maybe I'm going to look for something like, doing a price check against one of my programs, and I'm going to define the scope against this assembly, against the parts here. I'm going to do some refinements, so I have content that's in different sort of space areas. I'm going to just look at my aerospace content right now. And then I'm going to create a view or understanding of all of this data by clustering this information together in a way where I'm going to look for things that are almost identical. Maybe I'll change the size to be, say, 10%, close to size, maybe by 10%. Looking at a price relationship, perhaps of 20%. So I'm going to analyze based on material cost, pricing, etc. And from here, I could even use categorization, so I can put aerospace / whatever, and I could use this for classification, but we can talk to that in a little bit. Now, I've taken this group of parts, 900 or so parts here, and it's actually built now in just seconds or two, the potential information of clustering identical parts together based on the parameters that I had. And if I want to get some warnings around this and sort of resort which ones may have differences in price, and then I can quickly click into, say, a cluster of parts here to bring up this particular part view. Let me close my tags here. And you can see where I've got a group of parts with different prices that are allocated based on their similarity and scoring. I can then select all of these. I can do a comparison across all of these. So I can do a side-by-side comparison. They're pretty much all 100% identical in size, shape, etc., but they're made from different materials. And you can see here that there's a price per volume difference. So even if I'm looking at specific materials, like these two are both plastic, I am seeing a price variance between these two, potentially because of the location that they're at, but it could be also supplier related, etc. So this enables me to analyze the data using these AI sort of tools, looking across all of my parts for, say, pricing of variability. So I can select parts that are the least expensive, that suit the needs that we have, and then could potentially publish this back to the engineer to say that of these two parts that are both plastic, this one has actually quite a bit less, so I'm going to make this one the preferred part, and I'm going to list this one as an alternate part potentially, and then it will drive. We can publish that information back into the organization to validate this, walk through, and then that gets published back to the engineers in a way that when they go to select a part, they will see preferred parts coming up sooner. They can see this based on price, or we could do it based on weight. We might have, a situation where I'm building an electric vehicle, or I'm working in the aerospace and building a drone where weight is an important aspect of the design phase. So we can set different preferred parts based on these areas. We can also then also set up classifications. These look like they're sort of seat rails. We could do, you know, a classification mechanism, which will show up as the engineers do searching for it in a taxonomy classification library to allow them to quickly narrow down parts when they're doing a part search. And we'll show that in a little bit later. Okay. If I go back out here, I can run a different kind of cluster. I'll create a new universe here of parts, and maybe we'll just do this one as a, you know, a car assembly. Once again, typing is always one of those things that are fun to do in the live demo. And I'm going to do an assembly analysis. So here I'm going to define the scope where I'm going to look at an assembly. I'm going to take an assembly. Once again, I can go in and look at maybe the automotive area. We'll narrow down to this particular object, which is a vehicle, as the assembly. I'm going to say okay. And for this particular assembly, I'm going to define the scope of all the parts. And these parts could be based on any given area. So when we talked about cross-program analysis and understanding where parts in one program could be used in another, this is where I can analyze where the parts in the automotive assembly could have had an alternate part maybe in my aerospace group that I could potentially reuse at a better price, better quality, you know, et cetera. So I'm going to say I'm going to look across all of my parts in the system. For this, I'm going to do a run the scope here, almost identical. I'll look at sizing based on here. You know, maybe I can set up for a subclustering by material, but I won't bother. And then I'm going to run this, and as you can see, it's actually running this right now. So it's doing an iteration. So it's looking at every single part within the assembly, and then it's checking to see if another part is similar in shape and size, and if any of those could be reused or could come from an alternative site. So here we can see one that looks like a battery tray or something along that line. We can see that there's actually a price difference between them, and that we could potentially save based on all the models that we buy for the year, you know, in this case, €700. Once again, I can look at the, compare these side by side. Decide which ones we want to make standard, publish the standard one. In this case, you know, for the one that's least expensive, that would be this one here. So we'll make this one the standard or preferred part, and this one's the alternative, etc. Once again, validate these, assign the workflow to approve them, and then notify engineering that, you know, we'd like to see if you can make this change. What's the cost of the change going to happen in the design process or in the next release of this particular vehicle in this case? Okay. So this is where we're using sort of AI to analyze information, define alternatives and potential and standard parts through the tool sets to be able to publish that information back to the user community where they're actually selecting parts, so that it becomes a normal way of them actually looking for components, looking for parts, and then reusing parts that already exist in the system. And once you sort of do this sort of standardization, classification, preferred analysis, and publish that back in, then the engineers in the process of doing their daily work can bring up the one part reuse application, where you can see here I've got about 2,000 parts in my environment. I can easily narrow down to maybe looking for parts that are in a specific location, specific storage location, maybe of a specific part type or family of CAD. As Ken mentioned, we're agnostic around this. But here I can do simple searches. So I'm going to look for something like a bracket, and you'll notice I'm actually misspelling it, because we all know engineers when we're in a rush, and obviously you've seen from the way I type, I misspell things as I'm typing all the time. But we can see where we can find things that sound like or look, you know, close to, so that in data sources in many organizations, they use an SQL query where if you don't spell it exactly right, you're not going to find it. Here we can give you a little fuzzy search capability. And then I'll select this first bracket. And once again, through the UI, without having access to the application necessarily, I have the ability to bring up a 3D model. I can zoom in and out of it. I can actually bring up some tools to do some measurements across the application, this particular part, to see if it's going to be, you know, suit the need that I need it to fit in this space or whatever. But I can also see that we've automatically recognized individual information around that particular part from the CAD model itself. How many holes are in it? How deep are the holes? So we know the thickness of the bracket in this case, in any given location, how, diameters. Of course, these are in inches. You can actually change your preferences. If I need this in metric measurements, I can quickly have it recalculate and display this information in metric views. From here, we can, as I mentioned, we can get information from multiple locations and provide multiple data sources and provide a holistic or 360-degree view of this. So not only do I see this part, and the CAD information around it, but I can see where is it being supplied by, where is it actually located, what's the price volumes for it. And it automatically identifies similar parts in shape and size. So if I'm looking for a bracket for this type, I can select several of these. I can do a side-by-side comparison around all of these to determine which one is actually going to suit the need for what the particular purpose that I have, and then make that decision, or using the ancillary information or additional information that might be available to me that's been indexed from alternate sources, such as cost, delivery. If you're doing build to order, maybe it has to do with, how long is it going to take for a product to be delivered? Is it already in stock? Is it actually located in the country or the area that we're in? And as I mentioned, we also have the ability to look at, how many have we purchased if I have access rights to the purchasing information, or, where is it stored, along with the relationships. So this particular part has a parent-child relationship. This is the particular parent of this part. And I can see that, that particular part might be used in another parent, but here are the ancillary children components of that particular part and other parts that are assigned to it. So we can see similarity. We can drill through the content of the part and the part information as we go through this. Now, this is, of course, looking at it from within the 3D Experience platform. You can look at it in a standalone view if you're not running the 3D Experience platform to start with. But we can also see it in context of the actual design. So here I've got SolidWorks up and running, worked this in CATIA, et cetera, other CAD applications. And I can go into the SolidWorks environment and actually have access to this content and do the same kind of basic search where I might want to narrow down to content that is sitting in, a specific location, right? Just in the source, my PDM Pro Vault, perhaps. And then from here, I could do a search based on a part that I may want to bring in or take use of. There was one case I had with a customer who went through the application using text searching, couldn't quite find what he needed, but remembered from a demonstration that I had shown him once before that he could actually do a rough mock-up of a part, because sometimes it's quicker for an engineer to do a redesign than it is to use the normal search tools. He did a rough mock-up in about 1.5 minutes, created a part file, and I've got an example one here, and then I can literally bring it in from here to create a sample part, and then I could actually do a search against that part from the UI to see if there's an ancillary part here. I can show an example of that from here easily as well. So here it's going to take that part, as Ken mentioned, we sort of index and understand the geometry of this particular component or part, and then we can do a search against all of the parts in the system to see if something similar exists in shape and size, and then potentially then do that same comparison to look and see if it's the correct material, etc. So you can see here where I've got multiple parts that are similar in shape and size. They are actually located in some different sort of areas, right? So some of them are in the PDM Pro Vault. Some could be in the collaborative spaces. So I have 2 that are in each of the automotive and aerospace environments of my 3D space environments here. And I can narrow it down based on materials. So I'm only looking for ones that are made out of aluminum or plastic, et cetera, mechanical features. So the ability to drag and drop and locate these parts in context to that is pretty handy from a design aspect as well. Additionally, if I'm in sort of this design phase and I can't find the part that I need, we have access to this library of parts, right? An outside catalog called Part Supply. We can get it to come up here. Love the demos. So it looks like I'm having a bit of problems getting to that. So let's go through it from here. I'll bring it up this way. Of course, probably a memory issue on my laptop. So Part Supply is an online catalog of parts. It's free to access for the collaborative community, but we have the Enterprise Part Supply Enterprise that enables you to go and create your own sort of cloud-enabled parts catalog and then augment that with the external resources. Here, I might do a search. Maybe I'm looking for another bearing for my saw. I can do a search for a bearing. I can find one that maybe is based on a specific sort of catalog or type. Look for a component, maybe a roller bearing, or get some details around the classifications. So, mechanical bearings here, and then pick one of the bearings and then get some additional information around that. Not only do I see all the configurations from this given supplier, but I can download this model, bring that directly into my design. If you're running it from the UI of like the SolidWorks UI here, if I could have gotten my login to work, I probably timed out on the login, then would have been able to actually do a replace or an insert into my model directly from the Part Supply catalog into the application from here. Okay. So going in through here, not only do I see these configurations, but I can see other potential vendors that might have the similar parts and similar components, and I can get to other supplier related information. So I know where this particular part comes from, who the supplier is, relationship information around all of that, et cetera, for the sourcing that I can then turn over to procurement so that they can understand where I selected this part from, and then also, allow them to go and negotiate for the price directly with the supplier or the contractor. Okay. So once again, Part Supply has almost 1,500 content providers or suppliers, 60 million parts and components right now, and is continually expanding from there. Okay. So as we've gone through sort of these demonstrations, I am going through fairly quickly to provide for some time for questions, et cetera. We talked about part reuse, the part reuse, part reduce, as I mentioned here, the Part Supply, and then the last component or area that I was going to talk to, just briefly mention, is this idea where not only do I have the content of the parts, but I can take a look at all the different purchase orders, and sort of procurement can start to utilize this information, and supply chain can utilize this information for starting to see, new parts. What's the cost of a new part maybe projected to be? How are certain suppliers pricing based on, versus other suppliers? And these actionable sort of dashboards, you can drill down to like click into this. I can look at, information based on which given, supplier or buyers are working with this information, et cetera. So you have these sort of analytic views into the data through the procurement intelligence if procurement and supply chain people are interested in that kind of data, and being able to drill into both from an engineering as well as a procurement standpoint together. So that sort of covers my basic demonstrations for today. So let me bring up my presentation again. So as you could see, not just from an engineering and procurement standpoint, design and procurement standpoint, but this search enablement can help many places across the organization. I've seen cases in manufacturing where the material management or material handlers are bringing parts out to the line. They see a part that's been misplaced just sitting in a corner. They pick it up, they throw it into the storage bin once a week, once a month, once a quarter. Somebody has to go through there and try and figure out what are all these parts, because there's cost involved with those parts, and what is the part, where does it need to go, how to replace it. They could actually do some measurements on the part, and then use the parts of the one part reuse application to like identify or find it, or potentially even have a 3D scanner that they could scan the part, use the STL file, and then upload that to one part and have it actually help them auto identify it based on the shape and size of that particular part. That would be one case. From a tooling aspect, if I'm designing a fender for a new product line, and I could take the fender and look to see if I had a fender that was 90% the same that I did like 8 years ago, and know that all of this other tooling and the CAD models for all the tooling was in the system. I could see the link between the fender to the tooling, and then I have a starting point for all my new tooling where I'm 90% there, and only need to make some maybe adjustments on some of the jig locations and the mount points for it. So you can see how that could be reused to reuse your tooling and the working capital that you had from maybe a model year, a year or two before, or a new part design, taking knowledge back against the history of that around that area. Okay. So at this point, I'd like to turn it back over to Ken.
Thank you, Rob. Rob showed you a pretty powerful tool, and we're very, very proud and confident in its ability to work, but we understand it's a little bit more than a technology. And I like to use the analogy, it's like a golf swing changing. The technology won't work unless you use it. We've sold this a couple of times and heard from customers, well, I'm still seeing new parts being introduced into the system. And what we've done is started working with them to understand why, and almost 90% of the time it's people haven't even logged into the system. So we look at this technology, and we try to make sure that we look at the 4 main areas to help make sure that the technology is successful. And one of this study here shows that 70% of technology is purchased they fail to realize the value of the investment based upon the results that were expected to be delivered. And it's really, we say, kind of comes down to these 4 main points. You have to have the buy-in from the people, from the executive team, that this is the way that we need to run the business as far as looking for a new part. And we've got some companies that actually look daily at all the new parts that are being introduced. You can use the system to look at do parts that were created today. We call it creation date part search, and then you can then check that assembly or that list of parts against your database to see how many new parts were introduced that could have been used, had parts in the system and be used, and then try to work with the individuals that are the ones not doing the search correctly and making sure that they know how to use the technology. So people is the big thing we work with to help with user adoption, knowledge of how to use the system. The good thing about this is that our training takes days, not weeks. It can be up and running fairly quickly. The technology is advancing from different ways to, as Rob mentioned, to use it and add attributes and database. So we're constantly evolving the technology. And again, we've got identified processes for helping to improve new part introduction that we help to help share with customers to make sure that they can be successful implementing the technology. And one of our customers, as Rob mentioned in that last slide, those different use cases, Eaton Corporation, they've actually have well over 30 documented use cases that are above and beyond kind of the core reason they purchased the software. They are using it for identifying part shortages that they say have stopped and avoided plant shutdowns, inventory optimization, times where they've leveraged one part to utilize scrap and alternate part selection. So some really cool use cases. And in one of the comments, we've actually heard from a number of our customers, but in particular Eaton, talking about the cost-oriented mindset it creates. Once they understand that, they start to look at different ways that they can use the technology to drive efficiency and cost, using the technology. So it's an outgrowth of what we're anticipating, or we're hoping for, but it really is something that starts to change the culture of a company when it comes to cost. So I wanted to share a use case from Parker Hannafin, and this, if you wanted to go to their website, it's publicly shared information. They actually shared this information at their investors meeting on how they were expecting to make some of their profit goals for the year, and they call their process for this simple by design, but they were looking to create a new FET series part, and they wanted to make it a premium part. So they actually redesigned it, and they found in that redesign there's about 147 new parts that were going to be introduced by this new series, this new premium series, and they thought let's scrap that and let's see if we can use one part to see what we could potentially reuse in this redesign. And so in creating the new 59 series using one part, they found out of that 147, 123 of those parts, the new parts could be eliminated, and they could reuse existing parts. 100% of the functionality was achieved, so about 90% of the components were shared, and there was no additional capital cost, so they could use all the existing FET cells that were being used to create the new 59 series. And so their cost dramatically went down. They were able to leverage existing inventory, and they were able to deliver this new series to market months and months ahead of schedule, and to the point where they believed that they were first to the market with this new series, and help them capture some of the new market the new market sales. So again, this is, if you go to their website, there's a whole study on this. It gives you a whole lot more detail. It's definitely worth a read. And then, just some key takeaways that we wanted to leave you with. We're definitely going to help you quickly determine whether you can reuse a part, whether you need to make it, or whether you have an option to buy it. Giving you all of the information, the 360-degree view, integrating the ERP, the CAD, MRP, ERP, any information that has attribute information is key for decision making, again, without any kind of requirement for data translation or data migration. It's going to help shorten your design cycle time. The 3D geometrical shape comparison, Rob showed it, where you can look and set the sensitivity to 100 or 100% the same, or alternate kind of the same. We also, when he talked about the ability to publish those parts, we had one OEM who was looking for parts, and they had 100 of the exact same bolt. And again, for a designer, that's really difficult, right? They found the part, but now they got to decide between the 100, which one do I select? But so having the ability to have a combination of either your engineering leadership or your procurement or supply chain leadership, take that 100 parts that are available and maybe give you 2 preferred parts, an alternate part, and obsolete the rest. So when you're looking for a part, quickly which one you should select, maybe based on geo or whatever kind of criteria you might want to select for an alternate part. But making that experience as easy as it can be for that designer. And then again, the cross-division, cross-program accessibility. This is key, because we know data is everywhere. We know, like I said, with Parker and Eaton both having 30, 40 divisions, having that accessibility to the different environments, regardless of if they're running CATIA or Unigraphics or Creo, and whether that data is sitting in different PLM, different data sources, and then again, not having to migrate that data is key. And again, having that data, the minute that data leaves a system of record, it becomes obsolete, it becomes old. So making sure that the integrity of that data, location of the data is staying in the existing location is something that's very important, especially when you're thinking of leveraging or accessing data. If there's any kind of specific ITAR or export control, it's very critical that data doesn't get moved or doesn't get touched if it's not supposed to be. So that's it for me. I'm gonna pass it over to Maria for some questions. But thank you, and we look forward to talking to any of you. If you have any of these use cases or anything that we presented, we definitely would love an opportunity to share more with you and hear a little bit more about your specific use cases.
Awesome. Thank you, Ken. And here's our first question. Is a life cycle assessment per part also available?
Yeah, the system enables you to take a look at both the recently released version as well as getting an index that lists all of the released versions. So typically you could only see just the latest release versions, or you could see which ones are currently in whatever life cycle state they might be in. Hopefully that answered the question. So you have the option of viewing the data and narrowing the data down in that way if you decide to, if the organization decides to index it in that manner.
Yeah, so if that data is available, it can be indexed as an attribute. So, you know,
yep.
Similar to any analytics, right? If there's data there, it can be added as an attribute and a filter characteristic for, you know, your comparison when the index is being done.
Awesome, thank you. Next question. What if I cannot reuse the part because the tooling belongs to a specific customer?
Yeah, that's an interesting question. So if the tooling designs to belongs to a specific customer and they paid you for that tooling, then I would assume that you couldn't reuse that part, but you have all of the information to be able to create another set of tooling that you could charge the new customer for, and then represent the exact same part. And you wouldn't have to redesign the part, and you'd have all of the tooling information to create that part. So all of that would be reusable, I would assume. Unless it was a proprietary agreement with that particular customer, in which case then I would assume you'd have to create a new part. Hopefully that answered the question properly.
Yeah, and we've had questions about that before around, you know, even parts that are being, you know, that are export control or ITAR, you know, so if at least what we can show because when we think about not moving that system of record, so from a security perspective, we adopt all the security of that part that's been maintained. So we're not moving a part for ITAR or for export control. But if you wanted to use that part, then at least you know it's available. Then you could go then to, you know, maybe the owner of that and explain, you know, that we'd like an opportunity to use that. So similar to the tooling situation, you know, if you found it, you'd still be able to reach out to that supplier and see if you know, you could insert that into the system.
Awesome, thank you. Next question. The choice of parts depends on multiple parameters such as part geometry, dimensions, material, performance, cost, and so on and so forth. Is CATIA AI parameterized to be able to interrogate the database using multiple criteria to find the best part for reuse?
Yeah, so so what we were showing through the demonstration is really not a database, but an index of the data that's available from all the different sources that you decide to ingest as it relates and correlated to the given part. So if I'm looking at the comparison screen, that side-by-side sort of comparison, almost like I was on Amazon and I'm shopping for a part and they're telling me that other people are looking for these parts, maybe you want to compare them. The fields that are in there are extended or extendable based on the content that you have available for you. And that's all just done through configuration during the indexation phase typically. And that enables you to define which ones are higher in value when you're doing a search for a part. And that similarity scoring or the similarity can be more than just the shape and the size of the part, but could be also based on a ranking of material. Like, is it the same material that it has a higher scoring, so that similarity scores could be adjusted based on various parameters of information. So it could be also inclusive of like a location. If you remember those left-hand filters that I popped open and was able to drill down into, I could look at location, or I could look at you know, part type or category or material. All of those are configurable and extensible based on the data that's available when you go to ingest the information.
Yeah, so likewise, any of the CAD information, whole location, bounding box, any of that criteria that is in the CAD model that you want to use as an attribute for search and compare, that gets kind of set up during the installation phase on what attributes are typically important. You know, sometimes when we have people, when we talked about that missing attribute information, it's missing not because we couldn't find it, we couldn't associate to the part. It's just we were not told during setup that it was required. So, if the information's there in the CAD model or in a different source and we want to associate it to the part, we just need to know where it is, and then we can build the mapping to bring it into the attribute information related to the part.
Right. Yeah. As a matter of fact, Ken, in that particular aspect, we talk about the shape and the geometric shape of the part as a matching pattern for similarity. But we can do the same thing with hole patterns. We could do the same thing with like the silhouette. We could do the same thing with sectional views of a part to enable you to look for parts that have the same sectional views. Because they maybe have to align, maybe like a turbo that has to connect to an engine housing. And so that section view of that mount point, if I have multiple turbos that all have the same sectional view, I have multiple turbos that could mount to that engine, that kind of thing. So those things are typically set up during the configuration phase. Go ahead. Awesome. Next question.
Awesome. Yes, next question. Is the part pricing information being pushed from an external source, or is it inputted and managed in 3ds?
So typically our customers already have pricing information in their ERP system. So rather than replicating that data or putting it into yet another place where you lose control over the data, you lose security over the data, et cetera, our customers typically leave that data where it is. We ingest the data or the information directly either from the ERP or through like, a daily or weekly or hourly export of changed data. And then that could even be in a CSV file or in their data lake or data warehouse, because they're already running reports out of places like that. And we can bring that information in directly from there. We correlate that by, say, matching on a part number in the ERP system to the supplier part information. The supplier part number in the ERP system matches to the internal part number, and we can use that internal part number to match it to the CAD model. And that's how we actually can represent that data together, even though they're coming from multiple data sources.
Awesome. Thank you. Next question. Where the parts are produced also makes a difference. A cheap part from China could take 3 times longer to receive, and if you want to rush it, it will cost more to air freight it to the US. Geography is where the part is made is a factor for searching. So you want your part to be close to where you're manufacturing the part. Can you comment on this?
Yes. So information along that line can also be represented in these views. If you remember, I clicked, I think, within the one part reuse application when I was looking at the large model on the right hand side with the 3D viewer, and I came down below under relationships and they had pricing information there. In there, you could represent where is this part actually coming from and what's the lead time for typical lead time for this part. So, and then you could do that, use that information as well from a search criteria standpoint. Now that information, and once again, is probably sitting in an ERP system or an Excel spreadsheet or someplace that somebody's managing because the buyers have that information. And we're just trying to help provide a way for you to make that visible to the engineers to help them make a better part reuse decision. We typically don't normally care about what the content, where the content is. We can connect into so many different types of content sources, but we want to make it so that it interrelates to the data that the engineer is looking at, so it'll help them make the better part decision.
Yeah, so that location could be another attribute. We actually had a supplier who was using that one part during the COVID, and they were monitoring states that were closed for business or some of the manufacturing facilities that were closed. So they wanted to make sure they weren't sourcing a particular part in a state that was shut down. So, there's, we didn't really talk on this, but we can actually also bring in industry information. So we have a way to bring in all of the information that's out there and company websites, social media, any kind of information that's industry related outside your 4 walls and that could be then become an attribute. And again, like location, when you're setting that that alternate part up or preferred part, it could be based on geo, right? So if you're in the United States, you're selecting parts that are in the geo. We've got a lot of international companies that that use the product across the board, and in certain countries obviously are sourcing locally as well. So we definitely could set up different views that would accommodate that for you.
Perfect, thank you. Next question. In short, how is the similarity score calculated?
It's a secret sauce. No. So the similarity score, when we look at the parts, and I did that side-by-side comparison, I think one was like, the reference part, and then the one next to it was 71% or 71. That's based on actually ingesting the geometric CAD model, understanding all of the plane surfaces, the dimensional areas, the angles, the hole locations, hole sizes, and we create a set of data points for that. It could be 100, could be 150, or whatever. And based on those total number of data points, when we do, it creates almost like a signature of 100 different data points, and then we look at another part, and if out of the 100 different data points for that part, 99 of them are the same, then we know that they're 99% the same. That's kind of just a rough way of how it's sort of calculated in general.
Perfect, thank you. Next question. How much does it add to the software and maintenance to give companies this added capability? What license do I need? And can the license be shared amongst multiple designers?
So it is a named user license. And we showed a couple of different products, but from an engineering perspective, if it's just engineering part search, it's a named user model, and whatever we would, depending upon the number of parts we're going to index, there's no cost for the index, but we'll help size what kind of internal hardware you might need to index all of the different parts, but it's just a named user model for simple engineering design part reuse.
Yeah, but if we talk about like what does it cost an organization to create a new part, right?
Yeah.
If one engineer uses the product just one time and doesn't create that new part, it easily covers the cost of their license and probably at least one or two more.
Yeah, right? Easily.
I mean, just in general terms, right? So if you look at it from that standpoint, implementing it, well, I mean, that's just the cost of the license. Of course, there's implementation fees, there's hardware costs, et cetera. But just to kind of give you a rough idea, the ROI, actually what our customers are seeing is fairly reasonable. Well, extremely reasonable.
That's great, thank you. Next question, how long does it typically take to install and deploy the solution?
That's how much data do you have? So we have customers that have deployed, kick this thing off and deployed in weeks to months. Others are taking longer because of the extended kind of content sets that they have. Ingesting or understanding the CAD model as we're sort of indexing it requires computing resources. So sometimes it can be lengthy, and we don't want to disrupt the use of the original source location. So we typically, don't want to overload their transactional systems like their PLM or PDM or the ERP or their CAD storage location applications. So it really kind of depends on the amount of content. But I mean, we have customers, 25, 30 million parts in their catalog right now, or their index. That could take a few months to index.
While you're indexing that 20 or 30 million parts, you don't have to wait till the end. You can start using it right away. The user interface is downloadable and can be installed in a few, an hour.
User interface is actually just a browser, so there is
no
there's no client. Yep. Mm-hmm.
Yeah, so that's usually fairly quick. It's just the index, and then again, when we talked about the kind of wide ability to add a lot of different data, and attribute it to the part. Sometimes there's some mapping pieces to it, but it really depends upon, we're doing ERP, we're doing inventory, we're doing MES, quality systems, and if we want to do something industry related, there's some really interesting things we could grow into.
Yeah, but most of the deployments are agilely done. So like
Correct.
indexing the CAD models, and then later we'll come in with the ERP data, and then we do the mapping and the merging across that. Rather than trying to bite the whole thing off, you can incrementally improve things by just bringing in another data source. You've created a whole nother group of content that makes it that much more valuable for the end users for making their decisions. So
we didn't.
Yeah,
we didn't get a chance to talk about this. We have a process called Metrics to Engage, and it's a free process where we would work with you on looking at your data and the sources and do some samples and give you a kind of a ROM on what it would take to implement and cost prior to you spending any money. So that's a free service.
Yeah, and then there's that whole sort of process can also help you build a business case for ROI for their internal
Exactly.
use.
Yep.
So yeah.
Awesome, thank you. Next question. We have several common part number produced at various global suppliers, each with different pricing and logistic costs depending on receiving plant. How could this be handled to identify the optimum pricing as well as consider what available tooling, capacity, and costs are involved?
So we can ingest that data and either provide it in a tabular format, like a table, where you can see the differences for that given part based on location and receiving plants, et cetera. Or you could do an analysis to provide, or we could show using whatever algorithms you want to define during the configuration to give you the median price based on locations, to look at highs and lows. That information, if you remembered, I showed that procurement intelligence application. Those sort of analytic views can be also put in, depending on how it's needed, into the application to show you high, low, even range over time, history over time, how prices may have fluctuated or changed. All of that kind of information can be made available. Typically not done at the engineering decision-making process, but you could use that information to calculate a baseline for a given part in a specific geolocation.
So yeah, we have a lot of customers who use it in the bidding process for should cost pricing. So you look at it, what you think the part should be, and you can actually do an analysis on all your parts on all the parts that are above or below what the average cost is. And you can look at suppliers independently. Is that supplier and all the parts that supplier supplies to us, are there parts they're supplying above or below on average what the average price is from other parts that are similar? So in that procurement intelligence, there's a lot that's being used today in our procurement group and in the bidding world for establishing should cost, and a lot of suppliers that had to go back and ask for part price reductions. They don't have to go back to all their suppliers. They can go and look at what the should cost is and say, hey, here are all the suppliers that are above the average cost. We're going to ask more from them than the suppliers that have been good to us that are under the average part price. So there's some really interesting analytics that can be done on that. I've got some examples. If whoever asks that question is interested, they can contact me and I can send them some examples of what we've done.
Perfect, thank you. So we are over our time, so we'll just answer one more question. Can I compare parts in respect to sustainability criteria?
Yeah, that's interesting. So Dassault Systèmes is actually in the top, like, what was it, 50 or 100 companies for sustainability in the world. So I would say that yes, depends on where that data would be located and how you want to represent it. But I believe that yes, that would be the case.
Great, perfect. Well, that concludes our webinar for today. If we didn't get to your question, Dassault Systèmes will email you within the next couple of days to answer your question. Thank you again, Ken and Rob, for a great presentation, and thank you attendees for joining us. We hope to see you all again for future webinars. Bye for now.